Hello guys, in this tutorial I'm going to solve question number 7, paper 31 June 2022. The complex number u is defined by u equals square root 2 minus a root 2i over 1 plus 2i, where is a is positive integer. Express u in the term of a in the form of x plus iy, where is x and y are real exact. Let's start now to rationalize the denominator. It's root 2 minus a root 2i divided by 1 plus 2i by multiplying by the conjugate of the denominator, which will be 1 minus 2i divided by 1 minus 2i. Then u is equal to expand and simplify. 1 multiplied by root 2. Root 2 times 1 is root 2. Then root 2 times will be minus 2 root 2i. Then minus a root 2i. Then negative is positive 2a root 2 into I squared. All divided by 1 minus 4. If you write this part, 1 times 1 is 1, then minus 2i, then plus 2i, then minus 4i squared. Cancel, I squared is minus 1, so minus will be plus 4. So u is equal to, try to simplify the real part with the real part. This is I squared, which is equal to negative 1. So the real part is root 2 minus 2a root 2. The imaginary part is included I minus 2 root 2i minus a root 2i, all divided by 1 plus 4, because I squared is minus 1, so minus plus, so the answer will be 5. How to write it in the form of a plus bi? The first part, it's root 2 minus 2 root 2a, all divided by 5. Then you can write minus after taking it negative 2 outside, will be 2 root 2 minus plus a root 2, all multiplied by I divided by 5. This is your answer simplified. He asked you to write your answer in the form of a plus bi. It's given now a is equal to 3. A is equal to 3. So you can simplify your answer. If a is equal to 3, you can start from the beginning, or you can start from this step directly and remove a and write it 3. Let's start from final step. Substitute by a is equal to 3. Start with this part. If u is equal to 3, if a is equal to 3, so this part will be 3 root 2 minus 3 times 2, 6 root 2 all divided by 5, and 2 root 2 plus a is equal to 3, so 3 root 2 divided by 5 into I. Simplify, u is 1 minus 6 is minus 5 root 2 divided by 5. And 2 root 2, 3 root 2 is 5 root 2 divided by 5i. Simplify your answer, so u is negative root 2, cancel, minus root 2i. Minus root 2 and minus root 2. This is the final answer simplified in case if a is equal to 3. Let's start now to find r and theta. R is square root of x squared and y squared. So from this complex number, when you calculate r is square root, this value squared will be 2, this value squared will be 2, so the answer will be 2. What about the argument? First, find theta, which is tan minus 1 y over x. When you write y over x, you will get it 1. Shift tan for 1 in red, you will get it y over 4. But this complex number x is negative and y is negative, so will be in the third quadrant. So to get your argument between negative pi and pi, don't forget all these cases, theta minus theta, pi minus theta, and the negative pi plus theta. So because this complex number in the third quadrant will be negative pi plus theta, so the argument of this complex number is negative pi plus the principal angle got pi over 4. So simplify will be 3 pi over 4. So now the final answer in REI theta 4. So the complex number is 2 e to the power of negative 3/4 pi. You can start your question from this part, remove a and cancel, write it 3, then multiply by the conjugate, then simplify. Now this is the final answer. This complex number written in polar form, argument form. He asked to write it in trigonometric form. This is the final answer. Using your answer to part B, find the 2 square roots of u. Give your answers in the form of REI theta, where is r more than 0 and the theta between negative pi and pi. Let's start now to explain how to get the square root, cubic root, fourth root, whatever, the nth root of the complex number written in this form. If you have a complex number u or z, u written in this form, r cosine theta plus I sine theta. Or in this form, u equals REI theta. How to get the nth root of the complex? The nth root will be nth root of r, whatever, square root, so n equals 2, cubic root, n equals 3, n equals 4. What else? The complex number written in this form, cosine theta plus 2k pi over n. I need a space, I will write it down. If the complex number written in this form, how to get the nth root of the complex number u. First of all, you have to get the nth root of r, then cosine theta plus 2 pi k all divided by n plus I sine theta plus 2 pi k divided by n. Where is k? Start from 0, 1, 2, 3, and so on. K. For k, if I ask, let's say, find the square root. Square root means n is equal to 2. You will get 2 roots. Use k equals 0, you will get the first root, and the k equals 1, you will get the second root. Let's say if I ask to get the cubic root, so n is equal to 3, and the k, take it 0, you will get the first, take it 1, you will get the second, take it 2, you will get the third. By the same way, if your number written in this form, REI theta, you want to get the square root by this way. Let's back now to part B, the complex number written now in this form. U is equal to e to the power of negative 3 over 4 pi. Ask to get what? The square root. We have 2 square roots. In general, square root of 2, then e to the power of I, but now theta is the value negative 3 over 4 pi. We add to it 2 pi k divided by 2, whereas k take 0 and k take 1. If k 0, the first root will be square root of 2, e to the power of I, remove k and write 0, will be negative 3 over 4 pi, all divided by 2. you can simplify more square root of e to the power of -3/8 pi I. And when k is equal to 2, so the square root of 2 e to the power of I -3/4 pi plus remove k and write 1 will be 2 pi all divided by 2. Try to simplify. This answer will be √2 e to the power of I. If you multiply up and down by 4, or you can use your calculator to get the exact value directly, will be -3 pi plus 8 pi divided by 8. So it will be √2 e to the power of -3 pi and 8 pi is 5 pi. So the final answer will be 5 pi over 8 into I. This is the second square root and this is the first square root. Thank you.